I'm Nishant Shastri. I'm from King's College London. We are here at the Mobile World Congress in the Innovation City, where we are showing the results of our research, where we are doing multiple different EU projects on various different aspects of 5G. And this demo here is particularly showcasing the need for network slicing. So unlike 4G, which was all about one single big bang about bringing broadband into telecom networks, in 5G you're going to have multiple different applications with completely different use cases. And each of these use cases come with different KPIs. And if you don't support these KPIs, then these applications are not going to work. And the only way we're going to make it work is by isolating these applications into completely different slices, so that you actually end up with a network as a service. So 5G is going to deliver as a service, let's say remote telesurgery, or 5G as a service for connected cars and so forth. In here we're going to show the impact of what happens if network slices don't actually exist. So here, Frank is first going to draw a very simple drawing, and the thing to notice is that the latency here is very low, 4 milliseconds latency, which is what you would expect for something like telesurgery. We're just doing drawing here because we don't want to be killing people. And let's see what happens when Frank draws. So the thing to notice as he starts drawing is to see how smooth or not smooth it is, because it's very important to get the tactile feedback. And this is important for telesurgery, important for drawing, important for all sorts of applications where you're actually having to feel what's happening across the internet. And you can see that it's very, very smooth, very, very clean, and it's almost instantaneous. So what's happening is that Frank is able to feel almost as if he were drawing directly on the screen when he's actually drawing on using this robotic arm here. So if you move from here, Frank, to the next higher latency of 120 milliseconds, which is way beyond what can be supported for an application like robotic telesurgery, you're going to see when Frank tries to draw, it's not smooth anymore. You can actually see the robotic arm kick back, because that's the haptic feedback that's coming from the other side of the internet, and it's actually forcing the cursor in very wild ways. And imagine this is happening for a drawing. Imagine this is happening on an actual surgery happening, and you're trying to cut up somebody's stomach. You're actually going to end up cutting their pancreas or kidney or whatever. So it's not something that would be sufficient to support a robotic telesurgery, and this kind of illustrates why we need network slicing. We have two different projects, one called Virtuin, another called 5G Norma, where we're looking at various aspects of network slicing, software-defined networking, and so forth.